Today we're here to talk about the 4 gig USB tool by the Mod Shop, aka Element 18592. This is a new product. I wanted to show the backside, but this is basically a substitute or replacement tool to use to read and write 4 gig Xbox 360 NANds. So this would be for Corona motherboards that actually have the 4 gig onboard. And what you can see here is that the connections and the numbers actually should be familiar to anybody who has considered or used the SD tool. So this is essentially an SD tool without needing to rely on an external SD card reader writer. So this guy, when you wire up, right, you have to plug it into a USB based SD card reader writer. But this has its own USB connection on it, and you can wire it in, or there's a couple of options for wiring here. So included with the 4 gig USB tool here are a few things. There's this little custom cable that adapts to this pin header. The pin header itself is just one is included. That would get soldered onto the 4 gig NAND header. And then there's a little bit of pin header, I guess. This is also pin header. And the idea here is that you could use this to mount to the tool and then use the custom cable to plug into here. So I'm going to go ahead and actually test drive this thing. What I'm going to go ahead and do is actually solder this so that it is connected to this header. And in a way that it can be reused over and over again. All right, let's have a look at that alignment. So, pretty good through here. This one starts to get a little, I don't think we're going to have a problem with that. So, let's go ahead and tag these. So now we've got a nice set of connections available on our tool. And then this guy, if we need to, can just plug in just like so. Right? And then this has the slots in it. And so when this is on the motherboard, right, this is going to plug into here. All right, so here we are with a Corona 4 gig motherboard. You might want to check out this image. Let's see. So if you go to the guides, you go to the Corona 4 gig, you can see this. We've got an existing video, how to identify Corona versions and why they don't matter. But then this image specifically, right? If you look at the 4 gig NANds, you can see that there's distance between the little chip that you'll see on top and these edge pads. Whereas on the 16 megabyte NAND Coronas, you'll see the chip goes clear to the edge and has contact with the pins. So as you can see in this one, this is one of those versions that does have a 4 gig NAND. So we'll be using this set of pads to read and write the NAND. So the goal here is to connect this device, the 4 gig USB tool, to those pins. And the way that we're going to do that in this first section is by using the pin header that comes with this tool. So we're going to get it on there. We'll solder the connection, and then we'll use this cable to read or to connect it to the USB tool. Okay, so my tip on how to get this header installed with proper alignment, right? Because we talked about how important that is to have it be precisely, exactly aligned to the pads, is actually just really basic. It's to use a piece of Scotch tape to hold it in place, right? So what you're going to need to do is get the tape over halfway or so and use that as the tool to position it, right? And then once you get the position exactly right on the end ones, what you can do is just tack it down with the Scotch tape, and that can serve as just a little bit of a holder for the end. Stay off of those end pins because those are going to be what you solder down. And once those are in, then it won't move on the rest of them, right? So look, I got both sides down. It's in position. I can wiggle the board. It doesn't shake loose. And to me, the alignment looks pretty good. I'm getting right up in there with my face. I'm going to rotate it. I'm looking down. Now it's hard to see through this particular Scotch tape a little bit, but I mean, if the end pins are aligned, then the rest of them will be as well. So I think we're pretty decent. So now what I'm going to do is actually tack down that 15 and 16, so these end pins here and here. So I've got my rosin core solder, so that means it has a little bit of flux in it. I've got the tip of my iron clean. My iron is nice and hot. I like to work hot and fast. And so what you're going to see is I'm going to hold the tip to it. I'm going to melt a little solder. We're looking for that wicking kind of behavior. So you can see how it kind of wicks into the pin. And then we're going to repeat the process on this side. So we're going to hold it at a little bit of an angle. There we go. We got a little bit of a wick. So this other side didn't have quite as much solder on it as I would like. I like to see a little bit of a kind of a hill on there, but yeah, that's all that's really necessary is a tiny little bit just to make that connection. So now that I got that on there, and more on the left side than the right, and that's okay, I can go ahead and lift this tape off, and we can inspect before we do the rest of them. We can inspect that the positioning of the pins is good. So I'm going to get way down up on there. Okay. So I wonder if I tilt it, if that would be. Yeah. Yeah, there you go. So in this way, at this angle slightly, you can see how each of the pads is lining up real well with the pin, right? So as we add the solder and drag our way through, we're getting that adhesion there. So the other thing to consider is that you don't actually have to do every single pad. If you look at the diagram here, you can see that 5, 7, and 9 are unused entirely. 8, 10, and 12 are unused entirely. So it's not totally necessary to hit every single one. So we definitely need 1 and 3. And in this orientation, it's the same direction as the reference image. So here we go. All right, getting a little lead of solder on that, so I'm just gonna clean up. There we go. All right. So now we hit the next pin. This is rather difficult to do underneath a camera. It means I have to work sideways. So that's that side. Just give it a good look here. Flip side. There we go. Okay. So those middle ones, again, are unused. I didn't need to do both grounds, but I went ahead and did. So now, if we look at this alignment, right? So this is the orientation from the photo, the reference image, and there's the reference image, right? So that's why we skipped the couple of unused here, and we could skip the couple of unused on that other side. So now we're ready to potentially wire up our crystal area. So this side of this is where we wire to that C wire. So I'll go ahead and just prepare that to receive a wire by just getting some solder on that pad. So we'll just go ahead and put my iron on there and just tin it up. All right, so now it's got a nice little ball of solder there ready to accept my crystal wire. All right, so now we need to connect the tool and attempt to read the NAND on this console. All right, so now that our pin header is installed, our next step would be to read the NAND. But I'm going to stop and make one strong suggestion here. After you've soldered in the pin header, before you've read or written anything to the NAND, I would strongly suggest doing a test boot at this point. So all you've done is add some extensions to this header, right? And then also pre-tinning this. So there's no reason, if what you've done didn't damage the console, that it shouldn't still boot retail. So stop here, test boot your console, make sure that you haven't triggered anything here, because proceeding at this point, if it doesn't boot, is foolish. So do that first. All right. Now that we've boot tested the console, right, we verified that even after our installation, that it still boots retail. One thing that I've gone ahead and done is on this connector that comes with it, you'll notice that one of the wires bends off on its own direction. And that is the wire that goes to that crystal spot that we tinned earlier. So this one. So what I did is I actually just tinned the end of that wire, which means I just put a little bit of solder on it, and then that's going to get connected to here. Now the orientation for this cable is important. It literally reverses the connections if you install it the other way, right? So the directionality is important to go this way, which should be fairly easy to keep straight because that's what places the crystal cable in the right way to head that direction and make that connection, right? And then the tool itself also has the C line, right? So it has that crystal one identified, so that if you look at it, when you connect this to here, you're going to connect the C to the one that lines up with that wire that goes off to the side. So the C crystal line goes there, connects off to the side. So my advice would be to go ahead and plug in the cable to the tool first, because it does take a little bit of force to squeeze this guy together, and what you want to avoid is like accidentally tugging once this is on there and damaging the motherboard. So you really want it to be a one-time connection, and it doesn't get a bunch of yanking on it or whatever. So what you can do to make this a little easier is kind of flex that ribbon cable so it's upward, and then you can kind of line it up, and you just want to be real gentle and just not force it, because what you're looking for here is for it to just slide on without too much pressure, without too much work. It just kind of pushes down. If it takes a ton of force, then something else is going on, something's not right. And then now we can go ahead and connect our crystal wire to that pad that we tinned before. So I'm just going to go ahead and throw a little bit of heat on there, and now our crystal line is connected. So now our tool, which still has our USB connection on it, right, is ready to be plugged in, and we're ready to read and write the NAND. So I'm going to go ahead and supply standby power to the console. So I'm just going to go ahead and connect to power, but I'm not, turning it on or anything. So the console's got standby power now. And then I'm going to connect my USB cable to my tool. And you should see some blinking. And what you should see, likely, very likely, is a pop-up that says you need to format this disk, before you can use it. You really, really, really don't want to format this disk, right? We're trying to read this thing, not format it. So you want to say cancel to that activity. Now, I believe you could use JRunner for this, but I'm going to have a link on the product page for this product. And I'm going to strongly, strongly suggest that you use this little 4 gig SD tool mod shop tool. It's a single executable. It works reliably, that sort of thing. So we're going to hit refresh drive list, and we should see there's our removable drive, right? And then we should be able to read our 48 megabyte dumps. And we're going to go ahead and just save those off onto my desktop, NAND dump 1. And so you see the percentages go in here, and if I can switch quickly enough, you can see the LED blinks pretty good while it's doing the read. And we'll actually do a second read, so I'm hitting the button again, and it automatically is suggesting the name NAND dump 2, right? Because there's my existing one, here's my NAND dump 2. So I'm going to go ahead and save that, and I'll switch back to this view, and you can see the blinking is indicating that the activity, that's an activity LED, is done. So we've got 2 successful reads here. So I'm going to go ahead and use the compare functionality to compare the 2 NANDs. So it asked me to provide the location. So I'm just going back to my NAND dump 1, going to my NAND dump 2, and I'm going to say compare. It says dumps are the same, right? So we have 2 identical NAND dumps. So now I can disconnect my tool, so I can unplug it. I can then unplug my standby power from the console, and I've got my my NANDs ready to write my ECC file or any of that sort of stuff. So we've successfully read the NAND twice, and we could proceed with our RGH process. Now, it is necessary if you want to read or write to have that crystal wire connected, but if you want to attempt to boot the console, you kind of have to remove the crystal wire, so that this basically puts the NAND in external read mode is kind of the way I think about it. By having that wire connected, we're telling the console we're going to externally access the NAND, so it's not bootable at that point. And then we can unplug our cable, and we're ready to reuse our tool. And if it ever becomes necessary to recover this console, it's just as simple as that single wire, and then reconnecting the header, and we can read or write or do whatever we need to the console. Now, at this point, all I did was read the NAND. So again, just a piece of advice, you could once again boot test the console. Prove to yourself that nothing in that reading activity actually, brought it down. So that is what we've got here. Thanks for watching. An alternative that I personally will probably take advantage of is using something like these DuPont connectors, right? So these DuPont connectors can plug in to this the same way, and then you could solder this directly to your board, or come up with something else there. So you could wire directly to this guy as well, but one of the things that's a concern with this reader writer and has been an issue in the past is the wire length. These don't tolerate exceptionally long wires being connected to them. So